Welcome to Clements and Lee's Improper Integral Emporium! Today in the Calculus Emporium, we will be working with this free response question from the 2010 Form B of the BC Calculus exam. As you can see, looking at this here, Part A is a really simple max-min problem with derivatives, and Part A, that is, and Part B is an improper or integral problem. So let's get on into this. First of all, we have two functions, f of x, which is equal to 1 over x, and g of x, which is equal to 4x over 1 plus 4x squared. So in Part A here, we've been asked to find the absolute max and min of g on the interval from 0 to infinity, or where x is greater than 0. So this is child's play. Start out simply. Find g prime of x, which is found easily by the quotient rule. So I'll just knock that out real quick. And this simplifies nicely to this fraction. So looking at this, we now need to find the critical points of this function so we can do a sign test. And for g prime, that's really simple. We just set the numerator equal to 0, and we get x equals plus or minus 1/2. Now the nice thing about the fact that it's x equals plus or minus 1/2 is that we are only looking at on the interval from 0 to infinity, so we can draw our sign test here, and then we can basically just cut it in half and ignore all this stuff. Not there. Whoosh. So our test points, I use 0 and 1 because they're really nice. Quickly show you that you'll get a positive number here and a negative number here, meaning that function g is increasing from 0 to 1/2 and decreasing from 1/2 to infinity. And that means that we're going to have a maximum at 1/2. It also means, if you look here, that we're not going to have a relative min, so you can go ahead and cross that off. And also, since that's the only maximum on the entire interval, that's the absolute maximum, which is what the problem asks for. To find that absolute maximum, we just plug in for g of 1/2, and that gets us 4 times 1/2 over 1 plus 4 times 1/4, which equals 1. So, A, done. The absolute maximum is at 1. And one little thing I forgot there is, do not forget to label your sign test. This is a sign test for g prime. If you don't label your sign test and the grader's looking at it, they might think it's for g, or g double prime, or f double prime. I don't know, something, but what is it? I don't know. Label everything. Make it really easy for them. So moving on to Part B. Part B is the part we're really concerned about, and Part B asks for the area bounded by the vertical line x equals 1, and between the curves f of x and g of x. Quick reminder that f of x is equal to 1 over x, and g of x is equal to 4x over 1 plus 4x squared. So, starting out, what are they asking for? The area between two curves. That should immediately make you think integral. So, since it's bounded by the vertical line x equals 1 and infinity, which is the question asks for, this is our integral. So, first things first, this infinity is important. It tells you that it's an improper integral, which means you have to rewrite it as a limit. So, I use b, it's my favorite constant when it's the top one. I use a when it's in the bottom. So you have the limit of the integral, and it's the same as before. So then it's just simple integration from there. You find the integrals of these. The integral of f of x is really easy. It's 1 over x, so the integral of that is ln x. However, the integral of g of x is not so easy. You have to do a quick little u substitution here, where u equals 1 plus 4x squared, and that quickly shows you that the integral of g of x is 1/2 times natural log of 1 plus 4x squared. So once we have that, we can go ahead and plug in our bounds using the fundamental theory of calculus, fundamental theorem, and then we can calculate our limit. So again, we have our limit over here, right in the corner. So we have the natural log of b minus the natural log of 1 for f of x, which works out nicely because the natural log of 1 is 0. So that part's done. And then we have the natural log of 1/2 ln 1 plus b, or 4b squared rather, minus 1/2 ln 5 for our plugging in for g. So this can be simplified in many ways. It's actually a tricky simplification in that I would never have guessed how to do it, I don't think, without a lot of thought. So we can simplify this down, first of all, to this, which then, using the simplification rules for natural logs, becomes the natural log of b root 5 over root 1 plus 4b squared. So still straightforward up to here, but this is where you have to get crafty, and that is the crafty thing you have to do is change it to the limit of the square root of 5b squared. So just taking your b and putting it under the radical, and that allows you to take out that radical. In fact, you probably don't have to do that in the first place, but it certainly makes things easier when it comes to the logic here at the end. So looking at this here, your answer in almost its final form, you can plug in for b, and the limit of this is 5/4, or the natural log of 5/4. So you have 1/2 times natural log of 5/4, and that is your answer. If you have any questions, or if I was going too fast, feel free to submit comments on the main page, and I will gladly correspond with you as to how I got the answer I got. Thank you, and I hope you've had an excellent time at Clements and Lee's Improper Integral Emporium.